Exercise 10F2, question 6. Here in the book, the sum of the first three terms of a convergent infinite geometric series is 19. The sum of the series is 27. Find the first term and the common ratio. So this might be a harder style question. So we know that if we were to sum up indefinitely or infinitely, we would get the answer 27. They're telling me that this is a convergent infinite series. So I know that the R value lies between -1 and 1 in order for that to happen, because if it was greater than 1, then the series would just keep getting bigger and bigger and bigger and curving upwards. It's important for you to realize that if you only were to sum the first three terms, right, you need to be doing that using, maybe we use this version, right? You need to use your regular old geometric series formula. You shouldn't be using the simplified formula, because you don't have enough terms, right? If I had maybe 100 terms, I could say, well, you know, that's getting close to infinity. It's not really, but I could use the simplified formula for a very large number of terms with a high degree of confidence, but I can't if I've only got 3 terms, right? Okay. So, do we know any information? We don't know T1 and we don't know R, right? We just know the answers, okay? I'd be starting with this formula because it's simpler. Right? So I would say from here, it follows that T1 equals 27 times 1 minus R. I'll call that equation 1. We'll call this equation 2. Right? And then we could substitute 1 into 2. Right? So, and that will just leave us with R's. All right, so we'll be substituting out that T1. We'll be able to say, therefore, 27 times 1 minus R times 1 minus R to the n, all divided by 1 minus R, equals 19. Okay, let's cancel these out to equal 1. Simplify things nicely. 27, 1 minus R to the n equals 19. Okay, what's next? If we go over here, oh, I know what n equals. I should have put that in earlier, sorry. N equals 3 here. So there, here. I should be writing that in. I know n equals 3 because we've summed 3 terms. We're going to need to know that to solve it. All right. 1 minus R cubed. I'm dividing both sides by 27 at this point. Okay. So I get, maybe if we subtract 19 on 27 from both sides and add R cubed to both sides, then we'll be getting 1 minus 19 on 27. 1 minus 19 on 27 would be 8 on 27, which is rather nice because those are both cubed numbers. So when I come to take the cube root to actually solve for R, nice and easy, R will equal 2 on 3, right? Which is what I was expecting. I was expecting R to be between -1 and 1. All right. So given that R is 2 on 3, we can now find out what T1 was. Okay, so we can say, therefore, T1 has to equal 27 times 1 minus 2/3, which is 1/3. So what's 1/3 of 27? It's 9. Maybe I could double check. Do a little check. If I calculate this infinite series, do I get 27? So my T1 is 9. My 1 minus R will be 1/3 because R is 2/3. So 1 minus 2/3 is 1/3. And yep, 27. So all good, the numbers are working.